With an ever-growing human population, food availability and sustainability are issues that come to the forefront of politics and research. Interestingly, insects may be part of the solution to global food shortages. Over 1,900 insect species are currently consumed either as delicacies or staples in the diets of over 2 billion people around the globe. This practice of consuming insects is termed entomophagy. Insects have long been a part of the human diet. The documented history of insect consumption dates back over 2,000 years in parts of China. In the harsh desert environments of Australia, indigenous peoples consider insects an important part of their diet, not only in their day-to-day, but especially as buffer foods in times of drought, because many desert insects live for multiple years. In fact, scientists have unearthed archaeological evidence that suggests humans have consumed insects for over 1.7 million years. The wear patterns on bone artifacts discovered in South Africa match the modern tools used by the local indigenous peoples to dig into termite mounds, suggesting they were formerly used in the same way. The protein in Western diets comes primarily from farmed birds and mammals, and lacks an insect component. This may be due to the negative views towards insects, or because fewer large-bodied edible insects occur in temperate than tropical regions. While not generally considered an important food source, insects were consumed at least to some degree by many indigenous peoples in North America, though this practice is less common today. The Onondaga Iroquois considered ants a luxury food and enjoyed their acidic flavor. They also dug up and consumed the nymphs of the 17-year cicada. Other groups consumed these insects as a means to avoid starvation, although grasshoppers have been consumed as a regular part of the diet in several indigenous cultures. Grasshoppers could be collected with nets or by causing brush fires, and would often be roasted with a little bit of fat or dried prior to consumption. The larvae of flies that parasitize caribou were consumed by indigenous people around North America, such as the Chipewyan, the Inuit, and the Dogrib. The flies were harvested when preparing the caribou meat, and typically eaten raw. The discovery of entomophagy in other cultures was strongly stigmatized by Europeans. This stigmatization has spread even to regions where a historical cultural practice of entomophagy existed. For instance, the prevalence of locust consumption has changed in areas of strong westernization in Africa and Australia. This is partly due to the associated aversion to insects, but also because of the Western practice of purchasing food in retail outlets. Modern societies may eat fewer insects than their ancestors due to the reliance on packaged foods or domesticated livestock for protein. Although insects make up an insignificant portion of the diet of most of North America, Mexicans actually consume more species of insects than people in any other country. Foods like fried grasshopper tacos are tasty and nutritious snacks that are enjoyed by locals and tourists alike. Along with caterpillars and stink bugs, ants commonly make an appearance in Mexican dishes as well. Winged reproductive ants, called alates, are captured during the flight season and roasted, while ant larvae are considered a delicacy, sometimes called escamoles, or Mexican caviar. The harvest of these insects can provide an important source of income for many Mexicans living in rural areas. In China, grasshoppers and cockroaches are reared as a protein source for feeding poultry. Two intensively farmed products, fish and soy meal, can be replaced, at least in part, by the more sustainable production of fly larvae, which can be ground into insect meal for vertebrate livestock feed. This replacement reduces agricultural and fishing intensity and does not place additional pressure on other industries, as the flies can be reared entirely on waste products. The market for insects as food, both for humans and for livestock, is growing globally as insects are being recognized as a sustainable food source. The market for insects as livestock feed is already worth approximately $1 billion globally and is expected to see continued growth. Ironically, even if people today don't mean to consume insects, they are unknowingly eating more insect biomass than they realize. In North America, an average person consumes up to 1 kilogram of insect biomass in a year. This is because many foods have allowable levels for contamination with insects or insect parts. For example, 75 insect fragments are allowed per 50 grams of cocoa beans, and 250 aphids are allowed per 100 grams of hops, the amount of hops used to produce about 9.5 liters of IPA. Even once the knee-jerk aversion to insects is overcome, there is currently a lack of clear legislation to guide the use of insects as food for human consumption. Because there are no clear guidelines that state whether insects have been raised or produced at a standard conducive to human consumption, many of the large chain grocery stores won't stock or sell insect-based foods. This hinders the progression of entomophagy in developed nations, where eating insects is already uncommon. Entomophagy can have many benefits that make overcoming these challenges worth pursuing. Insects have potential as a human food source for several reasons, the first of which is that they're packed with nutrients. By weight, insects provide more calcium than milk, more iron than spinach, more magnesium and vitamin B12 than beef, and many other micronutrients and B vitamins. That being said, the nutritional content of insects varies by species and with their food source. Protein can comprise over 50% of an insect's dry weight, and many insects provide all 9 amino acids essential to humans. Some insects also store a high quantity of fats and can be an important source of natural fats, including omega-3 and 6 fatty acids. Although the nutrient content of insects varies by species, most are comparable to many of the animals that are regularly farmed and consumed by humans. Thus, insects can be used as part of a balanced diet. Although insects are a high-protein food source, not all of that protein is readily digested. The protein from the chitinous exoskeleton of insects is largely indigestible and so is unavailable to humans. That being said, the protein present in the whole insect is still significantly more biologically available than plant-based proteins, and the indigestible exoskeleton can act as a good source of fiber. Like many other types of fiber, the chitinous exoskeleton may contribute to the maintenance of healthy communities of human gut fauna. As we learn more about the microbes naturally associated with the human digestive tract, research has shifted to how microbiota can be promoted through the addition of probiotics and prebiotics to human diets. Probiotics are live microbes, bacteria in particular, that are consumed to complement the naturally occurring gut fauna, although research into the benefits of probiotics is ongoing. Prebiotics, on the other hand, include types of fiber that nourish the helpful microbiota already present in the human digestive system. Chitin from insects can act as a prebiotic to feed the good microbes of the human gut. While much of this research is still in its early stages, the consumption of prebiotics can positively impact the natural microbiota of the gut, as the digestive processes that may kill probiotics before they reach the intestines do not effectively break down prebiotic fiber. Most currently used sources of protein in North America and Europe are not sustainably harvested, which has resulted in concerns about over-harvesting of native fish populations and increased levels of greenhouse gas emissions from vertebrate livestock. Insects can be more sustainably reared on a smaller footprint of land than most currently consumed animal products. The sustainability of insects as a food source is due in part to the fact that insects are ectothermic, so there is greater efficiency in the conversion of food and water into edible tissues. Other than fish and bees, livestock currently farmed on large scales are endothermic. So instead of resources being converted directly into edible tissues, they are used to maintain the body temperature of the animals. The greater efficiency of insects in converting feed into meat means that rearing them requires the use of less food and water. In fact, a colony of crickets requires less than 2 kilograms of food for every 1 kilogram gain in body mass. Compare this to pigs, which require 5 kilograms of food for every kilogram of body weight. Cows are even less efficient, requiring 10 kilograms of food to gain a single kilogram of body weight. In addition, water consumption is far lower for cricket rearing than for endothermic livestock. Furthermore, the relative amount of the reared animal that can be eaten is greater for insects than vertebrate livestock. 80% of an adult cricket's body is consumable by humans, but only 40% of the mass of a cow is used as food, while the remaining inedible tissues have to be put to other uses. The rearing conditions for insects are also more efficient than for livestock or fisheries. Insects have very low space requirements for growth, so vertical spaces or small areas can be better utilized than with vertebrate livestock. For example, to raise a single pound of protein, cows require 6 times more space than crickets. Just as the manure of vertebrate livestock can be used in fertilizer and other applications, the feces of mass-raised insects don't have to go to waste. Frass from reared insects can be used to feed fish, either in raw form or by using it to culture plankton. This waste diversion strategy is already employed for mass-raised insects in other parts of the world, including mass-rearing facilities for silkworms. Insects reared for food also produce significantly less greenhouse gas emissions than current livestock rearing. The rearing of insects produces less carbon dioxide, the most significant greenhouse gas globally, as well as less ammonia, methane, and nitrous oxide than vertebrate livestock. For example, 90% less methane and 99.7% less nitrous oxide is produced per kilogram of body mass to rear insects compared to cattle. Insects may be a necessary protein source to feed the world's ever-growing population, and an important part of the solution toward food insecurity faced by much of the world. The short lifespan of insects also means quick turnover of feed into edible product, making it an even more useful food source when other resources are scarce or only periodically available. Insect farming is already taking off, with over $1 million worth of mealworms being exported from China each year. Because of their rapid growth and low resource requirements, insects like mealworms have even been tested for use as a source of protein for people in space travel and on space stations. Entomophagy is on the upswing in North America, and despite the challenges it faces in strongly westernized societies, many independent entomophagous businesses are now established. Many examples of entomophagy in North America are novelty items. For instance, whole dried insects that are seasoned or covered in chocolate or candy. While these novelty snacks are generally marketed as a fun alternative to typical treats, some insect-based foods are sold to constitute a staple in human diets. In North America, cricket and mealworm flours have been gaining recognition as protein-filled substitutes to standard wheat flour for cooking and baking. These insect flours are much more nutritious than standard wheat flour, And they can potentially provide a gateway to entomophagy, in which the consumer avoids seeing and chewing the whole insect while eating. The real challenge associated with entomophagy is overcoming the perception of insects by much of the population today. A study conducted by a company in the United Kingdom called Ento found that people were much more willing to eat insects if they could not see the insects in the dishes provided. In order to introduce insects into the human diet, the first step may be as simple as presenting insect-based foods in a visually appealing manner that will be accepted by the general public. If this can be achieved, introducing insects as a regular part of the human diet could provide necessary nutrients and reduce the economic and environmental costs of food production compared to many of the current animal food sources. Entomophagy is being brought to the forefront of society as we deal with issues of sustainability. Here in Edmonton, a local company is breaking the mold to include insects in the regular diets of people in the city. Covering everything from farm to table, Kamola Sustainable Foods includes insects, usually in the form of cricket flour, in all of their dishes. We spoke with the founders of the company and got a tour of their cricket rearing facility.
My name is Claudio La Rocca, CEO and co-founder of Camola. I am a graduate of the U of A from the Forestry Department, Renewable Resources Department actually, in Forest Biology and Management. In a nutshell, what we do is basically we take cricket powder, which is oven roasted ground up crickets, and we use it to make delicious and healthy snacks. So what we want to do is introduce people to the idea of edible insects in a way that is not too intimidating. They don't have to take one full cricket and eat it. Many people don't want to do that, so we try to transform it into something that is more familiar to them. They can enjoy it, they can get all the benefits, and they can actually understand and learn more about edible insects. So both my partner and I, we have a background in entomology and environmental sciences. So we've been studying insects and environment for over 10 years now. So we do know that food production and in general human activities have an impact on the environment. It requires resources, it takes water, land, and whatnot. So we try to combine that knowledge with the fact that we know a lot about insects and the fact we are both Italian, so we like good food. So we try to get the best of those three words and create some snacks that are actually a way to educate the market, educate people into environmental sciences and environmental conservation. So the consumption of insect is a way to reduce the environmental impact of our food, basically. The way insects are farmed, the way they're grown requires less resources, less land, and less energy in general. So it's a way to reduce the environmental impact of food production. In our products, we use basically mainly two species of insects. Common house crickets, Acheta domestica, and yellow mealworm, Tenebrio molitor. When we started, it was mostly no thank you, and I don't even want to try. But in the past year, we've been in activity for close to 2 years now. We've seen a change in how people react. Definitely the fact that we have been on the market for so many months helps people to understand what we do. They get a little bit of education and all the spiel on what we do, why we do it, what's the benefit, what's the reason to do it. Among our line of products, the most requested and the favorite crowd's product is probably our crick chips, which are basically like tortilla chips, but they are made with no corn, no potatoes. It's made with chickpea flour and yellow pea flour, and of course crickets and a little bit of mealworms just to increase the amount of protein. When we talk about cricket farms, people think that we have cricket just on a grassland, just roaming around, and we just scoop them up and process them. Everything is done indoor. So it's a small unit. You can grow as much as you want, but it's all done indoors, so you don't need that much land. You can farm vertically, so it's not that different from, let's say, hydroponic. So you can have different layers stacked on top of each other and increase the amount of protein you can get from a unit of land, for example. So the way cricket powder is made is very simple. You start from your crickets. Once the cricket reach anywhere between 5 and 6 weeks of age, they are ready to be harvested. So you take the crickets, you put them in a container and you freeze them. That's a natural way for them to die, right? So it's like winter has arrived. I don't want to say winter is coming because that show is over. It's like winter for them, so they hibernate and then they die. Once they are done, they are washed, they are oven roasted and then ground up. So it's a very easy, very simple process. It doesn't require any additives, any chemicals. The powder itself is very natural. It's 100% roasted or in other way processed crickets, and then they're ground up, and that's it. So the main difference between the way crickets are farmed for human consumption and the way crickets are farmed for pet food is mostly in the kind of feed we use. For pets, there is not too much discrimination between very good food and cat food. You can just feed your crickets. Doesn't matter what you want. There's a cricket that is full of protein, and you can just feed it to your salamander or whatever. For humans, we use basically feed-grade feed. So things that you can feed, a type of feed you can give to any farm animal that eats grains. The water is clean, the environment is kept very clean. So everything is done like if you were farming any other farm animal. So everything has to be done to avoid any contamination of the food, any infection, the water has to be clean, so no salmonella. It's tested, so we are sure there is no salmonella or E. coli that can get to the crickets. So when I was working on my first master back in Italy, I worked on carabid beetles.
Harvesting wild animals for food, including insects, comes with risks. Firstly, it is important to properly identify insects intended for consumption, since many insects can be poisonous or toxic. There is also a risk of pesticide poisoning, since harmful chemicals can accumulate within insects. This occurred following an insecticide application program in Thailand, where the consumption of dead insects from the area caused health problems in the local human population. The consumption of insects also comes with the risk of allergic reactions. Individuals with allergies to shellfish are likely to show a similar reaction to the consumption of insects because the chitinous exoskeleton shared by crustaceans can be allergenic. While severe allergic reactions from the consumption of insects are rare, they have been documented in people around the world. Allergic sensitivity to insects can also develop over continued exposure, which puts those that work in insect rearing facilities at risk. The ecological impacts of insect rearing may also have some drawbacks that are not immediately obvious. The amount of land, water, and energy invested into livestock farming depends not just on the species being reared, but also the food source provided. The ecological costs of grain-fed livestock production lie largely in the cultivation of the grain. One study showed that crickets fed chicken feed, composed of grains, showed only a small improvement in the efficiency of the conversion of food into protein compared to chickens. The same study showed that crickets cannot be successfully reared on low-quality waste, such as most post-consumer food waste. It seems that the next step towards the commercial production of insects is to identify good quality waste substrates on which to rear the insects, which are not in direct competition with demand for rearing other forms of livestock. While black soldier fly larvae show potential as a species that can be fed on largely unused organic waste, farming techniques for these insects are in the early stages of optimization. Automation of insect farming must also be further developed for insects to compete in price with other animal proteins, which have already been reared for thousands of years. Insect farming technology is still in its early stages of development, and there is still no standard procedure for farmers to rear or process insects. The environmental costs of processing insects for food is rarely mentioned. Since crickets are often ground into powder or freeze-dried, processing the animals can also require a significant investment of energy. It seems the potential for entomophagy to become a global source of dietary protein is more complex than initially expected. While entomophagy may have sustainability benefits compared to the consumption of other livestock, the fact that they are animals means they still need to be fed more food than what is produced. As such, entomophagy does not reduce the amount of agricultural investment when compared to substituting animal protein with plant-based proteins. This is a complex issue, though, as it may be possible to rear insects on some waste products, which would reduce the agricultural investment required to rear them. Furthermore, the biological availability of protein and other nutrients varies between food sources. While the protein from insects and other animals is largely digestible and available to humans, plant-based proteins are less biologically available to humans, meaning that a greater quantity needs to be consumed to meet nutritional requirements. Hopefully, this lesson has encouraged you to give the idea of entomophagy some thought. Even small changes in our diets can have impacts on sustainability and reduce the strain placed on our environment by the food production industry. The benefits of eating insects do not stop at sustainability, as an insect diet provides us with many essential nutrients. The future lies in improving insect rearing methods and overcoming the perception of insects as unpalatable creatures. Perhaps we need to start by using insect flour more frequently, or by marketing insects as the terrestrial prawn. Although the thought may be unappealing to some, the benefits of insect consumption make it well worth the effort.